Hi guys, this is Oliver from Garanga, Thailand. Today we show you how to set up a PCB station using an AUBO i5 robot and two RG2 grippers from OnRobot. They are connected to the robot with a dual quick changer. Beyond that, we use the logo and a Siemens PLC to operate the system. Let's have a look at the video. This is how the result should look like. The robot operates the grippers through the compute box by using the Modbus TCP protocol. Furthermore, the optic sensors of the 4 trays you can see here are operated through the logo, detecting if a PCB board is placed on it or not. Then we have the tester station itself, which is operated through the Siemens PLC. All the communication here happens through Modbus TCP. Let's have a look at the overview for this tutorial. First of all, we set up the tool center of gravity. Then we will set up the Modbus connection, including its signals. Next step will be the remote programming, and finally we will teach the waypoints. And last but not least, we will have a look at the program, how it's running. So let's go first into the web client from OnRobot. As you can see, the compute box automatically detects the gripper that is installed. So when we go now to TCP COG over here, we can choose our robot model. Unfortunately, AUBO is not yet integrated into the system. So we choose a robot that doesn't have an adapter because the dual quick changer is directly mounted to the tool connector of the AUBO. As the connected tools and the dual quick changer are automatically selected, you can see now over here all the data we need for the center of gravity. Next, we go to the AUBOPE software to set up our tool center of gravity. So in the software, we need to go to Settings, and then under Robot Tool Cal and Dynamics Cal. Here we can add the new tool with its center of gravity and weight. We do this so the robot can balance the additional weight that was added to the tool flange, especially in free drive. So as we have seen, we have a weight of 1.97 kilograms, and the center of gravity is only in Z direction, which is 100.1 millimeters. We need to give it here in meters. Finally, we will have to give a name to it. So we use dual quick changer RG2, just shorten it, save it, or click on add. And then we go back to Tool Cal, click on a free field, define a tool name. Again, we take DQC underscore RG2 for dual quick changer RG2. Kinematics we don't have defined, so we keep it with the flange center. And for the dynamics, we choose the just setup settings for our tool. Finally, we click on add and see our tool now in the list to be chosen. So now we have to log out of the system and restart. Make sure that you don't click on the shutdown symbol, only the logout symbol, so we can log in right away again. Here we have now the possibility to choose our tool, the one we just created, save it, start up, and our software will initialize again. The next step is to set up the Modbus devices. First, we should check the IP address that we have set up, which we have here already in the range so that our robot can communicate with the Modbus devices. Next, we go to Extensions, Device Config, Modbus. Here we can add the devices that are required for our program. All right, let's quickly go back to our presentation slides. We have here some slides to show you what we need to set up for all the devices that are used in our system. First of all, the Siemens PLC. We have the IP address and all the information we need to set up, like the inputs or the outputs, for example, here. Let's transfer this to our AUBOPE software. So first of all, we need to define a name. Here, just PLC. Use the modes TCP. The slave ID is 0. We have a response time of 500 milliseconds. Frequency we changed to 10 Hertz. And we need to put in the IP address. And finally, of course, the port 502. Click on Add. And you see already the Modbus device is successfully connected, so that we can go on to the I/O config and set up our I/Os here. So first of all, we need to give it a name, of course. Here we take the PCB sensor as an example, which has the address 0. And we need to choose the digital input type, because here we get only the 1 or the 0 from the sensor back. Finally, click Add and then continue with the remaining I/Os. We speed up this part of the video now just to get over it quickly. You have the overview in the presentation. For some I/O types, we choose register outputs. These are holding registers that we are able to read and write. So this is important, especially for the Siemens PLC, to be able to communicate with each other. Finally, we go over to I/O state, where we can check our inputs and outputs. On top, we have the digital inputs. We see the PCB sensor is not triggered, but the tray is outside of the tester. Now we can continue with the other Modbus devices. Let's have a quick look at the logo, how to set it. This one with the IPs and with the inputs. So when we go back now to the AUBOPE and put in the logo, we saw just Modbus connection failed, but now it's success. This is because we had a connection already, and if the robot wants to connect again, then we will get the failure message. So just click on connect again and it should work out. Now we add the I/O config for the logo, which are only the jig optical sensors, only digital inputs here. And then we continue with the OnRobot Modbus configuration. Here we have 2 Modbus devices for RG2 number 1 and number 2. The only difference is the slave address. And now we set up the I/O config with force, target width, the grip function, and actual width for each of the 2 grippers individually. For actual width, you can see we have chosen register input because we get here real values, not only digital inputs like 0 or 1. Now we can go over to I/O control to check the grip function of the grippers. For this, you can see on the right hand side the grippers itself. First of all, we need to enter a width. We take here 500 for 50 millimeter. And for the second gripper, we choose 200 for about 20 millimeter. Next, we need to send a 1 to the grip output. And we see it works. For ease of use, we have here also send 1 button. So for gripper 2, we use this, and we see also gripper 2 closes. Now we open the grippers again for the teaching of the waypoints later, that we don't collide with the boards when we teach the waypoints. We sent 1 again here to open the grippers, and perfectly they open again. The next step will be to go on with the programming. Let's have a look at the slides here. We will first add a base structure with home pose, loop, case evaluation, switch case, and in the end, the home pose again. Then we will define some cases, what we want the program to do. So I've defined 4 cases here: place in tester, pick from tester, pick from jig 1 or 2, and place in pass or reject tray. These are the 4 tasks the grippers can carry out. And this is a quite easy way how to structure the program. So we always need only 1 or maybe 2 for case 3 and 4. So let's go over to the OUBOPE to create a program. For this, we need to go to the Programming tab and click on to the New button. Okay, this programming part will take some time, so we speed it up for you in order to save you some time. Please feel free to pause the video at any time to have a closer look at it. So we added the home position already. It's just a waypoint. We added here later while teaching. We will add the real waypoint. Then we added the loop main where the program will run. So first thing we do is we add a block comment, the folder structure for the cases. This is just the block comment for the overview, so we can hide all the if functions here. The first case we set is place in tester. So the second gripper will have a board gripped and place it into the tester station. We see here all the conditions we add. For case 2, we will have pick from tester. This is the first gripper that will pick it from the tester, so that needs to be open, for example. And we have a few more conditions we set here. Case 3 is pick from jig 1 or jig 2. This means the second gripper needs to be empty, and we need to have a jig placed, a PCB board placed on jig 1 or 2. The last case, case 4, is place in pass or reject tray. That means the gripper 1 has gripped the PCB board from the tester and is ready to place it into the pass or reject tray, depending on the test result. Next, we go on with the switch case function. For the switch function, we need to define a variable that we use to define the cases. Then case 1, we just defined with the variable is equal to 1. We start with the home position in this case, and then move to the tester. We didn't define the waypoints here yet. I intended to leave them blank in order to have a better overview later while teaching the waypoints. Unfortunately, the program is not able to be saved as long as the waypoints are not defined. So we will take a safe waypoint close to the tester, and so we will add another move command to approach the release position safely. The second move command to approach the release position is a move line command to make sure that the robot moves in a linear way and not as best for joint acceleration and speed. So then when we reach the release position, we will add another block comment to release the gripper. This here block comment release 2. We will release it, and then we will retract from the position again, send the signal to the tester station that it can start testing, and we are finished, ready to go on with the next case. Case 2 is pick from tester. We have defined this already before, so we can go on with the movements and the actions. So here we need to move to the tester as well, this time with the first gripper. So we will follow the same guidelines as we used for case 1, just that we will grip here the PCB board instead of releasing it. And after retracting from the tester station, we will send a signal that we have picked the PCB board. The block comment test result we just saw here is to save the test result in a variable, because the tester station only gives us the test result until we send the signal that we have picked the PCB board. After that, it will be reset to 0, so we need to save it in a variable. Case 3 here, it is pick from jig 1 or jig 2. So here we need to work again with if and else if condition to define if there is a PCB board on jig 1, we move there, pick it from there, and retract. The same for jig 2 if jig 1 is empty. The principle is the very same like for pick from the tester, just that we use here gripper number 2 instead of 1. We will need to adjust the block comments for grip accordingly. Everything is otherwise pretty much the same. You can see us use quite often the copy and paste function. Here the block comments come in quite handy because only one comment can be copied, but for the block comments also the sub functions will be copied. Now we continue with case 4, which is place the PCB board in pass or reject. For this, we have the PCB board gripped already. We start from our home position and move to the reject or pass tray, depending on the test result. So first of all, we need to work with a if and else if condition here to check if the test was with a result pass or result reject. And according to our test result, we will move to the correct check. Also here we will move with a joint move into a safe position close to the pass and reject tray. And after that, we will move on to the release position with a move line. So we are almost done with the programming. We just have to define a default case that we don't have. So we just put a waiting time of 0.5 seconds. We continue now with teaching the waypoints. Also this part we speed up in order to make it more convenient for you. We have several options to teach waypoints. First of all, we have the free drive. You saw it in the very beginning of the video. I pushed the free drive button and moved the robot by hand into the position I wanted to start with. As this application requires highly precise positions, I rather use the teach pendant to move the grippers into the right direction. We have the possibility to use the step mode and define the step length we want to use from 0.2 millimeters to higher values there. With this, we can use very high precision positioning. I approached the PCB board to pick it up, defined the waypoint there, and then I actually gripped it in order to have the same orientation of the gripper with the PCB board gripped. This is actually a crucial point to do in order to succeed with the application. What you just could see is I programmed the release position first, then I just moved up in Z direction to define the safe positions. So it's a bit of in reverse order to make it easier to program these and to make the robot movements smoother. Now I moved on to the other gripper, gripper number 1. I start with teaching the Waypoint actually where to release the PCB board in the pass tray and continue with the reject tray. In the end, where you start gripping the board doesn't make a difference. You just need to make sure you have it gripped in the very same position for all the important pick and release positions. You can also see the gripper is inclined. This is because of a possible collision while releasing the board in the pass or reject tray with the tester tray. And this is also why I started to teach the waypoints at the pass and reject tray, in order to find out which inclination I really need in order to avoid a collision. While setting up the waypoints, I test forth and back a couple of times to make sure everything works smoothly in between the waypoints. Now we come to an end. I've released the PCB boards, opened the grippers, and now we proceed to test the program first manually. And you have just seen I already forgot one waypoint and the robot wanted to go somewhere where it was not supposed to go. So I fix this quickly and go on to pick one PCB board from tray 1, put it into the tester, check again, does it work fine, open it, all right, go on. So now we do the same from jig number 2, test if the waypoints all work fine, release the PCB board into the tester, that works, all right. Now we can go on to the next steps, pick up the PCB board from the tester and place it in the reject and pass trays. And as you can see, this doesn't work that nicely. So I go on and adjust the waypoints again for all these positions. That means the positions in the reject tray, the pass tray, and the tester. These need to be very congruent, very precise. Okay, so the adjustments are done. We can go on to the next try. We pick up the PCB board again from the tester and try to release it, this time into the pass tray first. Small adjustments to be made here. I check it again, I test, it looks fine. And now with the reject tray, okay, also a couple of small adjustments, but then it works and we can go on. After setting up the waypoints and checking the program, there were a few things I needed to adjust. So I added a couple of things and I changed a couple of things in the program. So first of all, we have here set in the beginning of the program, open the RG2s, which just means we open the grippers so they're ready to grip, so that we don't crash into the PCB boards. Another thing is setting the gripping force. We set it here to 8 Newton for both grippers to make sure that the settings are correct every time we start the program. Furthermore, I exchanged case 3 and 4. That means place in the pass or reject tray is now case 3, and pick from jig 1 or jig 2's case 4. This was just made in order to place the tested boards first before we pick a new one. It makes more sense for the movement as the grippers are already in orientation to release into the pass or reject tray. I removed the home positions in the end of the cases to avoid that the gripper turn around 180 degree, and then for example, to place the tested PCB boards on the pass or reject tray, it needs to turn back the 180 degree. This results in a smoother flow of the movements in between the cases. There was a mistake that I made for setting up the Modbus communication with OnRobot. The inputs here for actual width and for status needs to be given in hexadecimal. Furthermore, the status for gripped is actually 2, not as given in the manual 1. So I changed this as well. So, and finally, we can go on and see the program running. You can see it is prepared. Jig 1 and Jig 2 are occupied with the PCB board. The RG2 grips board places it in a tester, sends the signal to start the test, and picks up the jig from the PCB board from the second jig. After the test finished, we pick up the PCB board, place the new one in order to utilize the tester as much as possible, and then place the PCB board, the tested one, into the proper tray for the test result, which was reject here. The second test result was pass. So now I left the PCB boards inside the pass and reject tray in order to show you after there's another tested PCB board that needs to be placed, but now it doesn't place because both trays are occupied. After taking them out, the program will determine that it can place the tested PCB board again. Okay, and with this we now come to an end. Thanks a lot for watching, and if you have any comments, suggestions, questions, just leave us a comment below. There's also a link in the description below the video to download a complete guideline to this video, including all the Modbus communication setups and the program itself. If you have an application like this in your facility and you would like to get some support, some recommendation from us, reach out. We're here for you. Thank you. Bye-bye.